you doing? I am Tim Delesio. I am the CTO here at Techolution. And I'm starting a brand new series of tech talks, and this is going to be the first one. So I want to talk to you today about containers and VMs. So before I dive into VMs, let's get into the basics. If you had straight up computing and you had an application, you think your PC or your Mac you're running, you're probably watching this on, and you have applications deployed to it, that's what they call bare metal. Really, it's just applications in their purest form running on a host operating system. People do this every day. When you boot up your machine, you have an application running, and it's great. It's running. It's beautiful. So what is a VM then? And there aren't too many systems these days that still aren't using this. But at a minimum, let's at least get on the same page so that everyone's familiar and has a base knowledge here. Just to put it simply, really a VM is just a computer or even several computers that are running within another computer. So if you have bare metal in a box, then your VMs would sit on top of it. So let's define what that actually is. Like I said, it's a computer within a computer, or even better said, an emulation of a computer system. So you have a host OS that shares resources of a host computer, and each VM has its own underlying operating system. But it doesn't need to be the same as the host. For instance, you could be running a Windows machine, and let's say you need to test something in Linux. You can have a VM that sits on top of that Windows host that runs Linux. Same thing with Mac. Let's say you have a Mac and you want to run a Windows machine on top of it. You have these environments that sit on top of your host computer, and the hardware itself inside the VM, it really thinks it's real. So if you're running, let's say, Windows, and you pulled up your resource monitor and wanted to look how much RAM you had or how much hard drive space, you would just see that number allocated by the VM, what it actually given it. And it would think that it was real RAM that sat in its computer. It really doesn't know it's different, but in reality, it's actually all virtual. A VM also requires a hypervisor or some monitoring system to sit in between the VM and to host to help manage what's going on. So it needs to be able to control the input and the output and all that fun stuff that goes underneath the covers. So what about a container? What is a container? Well, first, just like a VM, a container needs to sit on top of a host OS, and it needs to help run everything. We also need some sort of implementation of containers. So in most cases, Docker is chosen. Docker is probably the most popular one. Almost everybody runs Docker these days. But there are other ones like Linux containers. And if you kind of stretch what a container actually is, you have things like Mesos and Cloud Foundry and Vagrant that do similar things to what containers were really supposed to. But let's get a little bit more into the detail here. Let's define what an actual container is. Like VMs, they also sit on top of a host, but instead of having their own copy of the operating system, they share the kernel as well as the binaries and libraries. And all this sharing that is done is immutable or read-only, so it can consume those libraries and those resources, but it can't make changes to them. So it really protects the host. It also reduces the need to reproduce a lot of the OS code and makes the containers much lighter. When you strip out all that code in the OS that you don't really need to copy from one instance to another, it makes it much simpler, much smaller. Containers has everything too that are baked into running the application. So all the application source code, the runtime libraries, and if you need any system tools or things like that, all gets packed into the container. So now that you have 2 and 3, if you count bare metal, but let's just call it 2, and different ways to run the systems, how do you choose which is the best one to do? So let's talk some benefits here. First, the VMs. So let's say you have an application, and your application is a tightly coupled application. It has, think like Magento or a WebSphere application or something that is a monolith, and it has some tight coupling with your database, and you can't really make a change to the application without making a change to the database. These are good candidates for a VM. You can put the database and the application in the same running instance, and it's together. It's hard to split them apart. So anything that is high resource intensive or tightly coupled, good use cases for VMs. And VMs have been running for a long time, like close to 20 years. I mean, that's a long time. This means that they're really well established in their security tool chains and practices. They have all the security figured out, all the tools are in place, and all the controls are defined and standardized. And you have if you need a very like fine-grained personalization of the image too. So, anything you can do in a host OS, you could do in the VM. So if you need to, set some environment variables or, make some tuning into the host OS, you do this in the VM, and then that just becomes your base, and everything else you roll against those changes as well. And since it's a computer within a computer, it makes creating a snapshot and backup of that system really easy. You can just image it out and boom, you're off and running. And then finally, the last, if you need full isolation of each VM, where a VM doesn't even know about the other VMs running it, another VM, good choice there. So, what about containers? What are benefits there? I mean, containers are all the rave these days. What are people really striving to get there? Why are they going there? Well, first, since containers have a lot of shared components, it makes the management of these very easy, and it reduces the size of versioning and all the day two operations, updating them, going through. It really simplifies this process. And think security as well. That simplifies all that, makes it easier to manage, easier to make changes. You have one host OS instead of all these different host OSs you need to manage. Makes it much, much easier. Less code. Means, you're not sharing or replicating all that code on the host OS. You're sharing it. It means it's less code in the container itself. This means that they're lighter. They're easier to transfer. They're easier to move places. They're easier to deploy into different environments. You can take that same container and you can stick it in a host OS in Linux, or in the same container in a Mac, or the same one into Windows. VMs, not so much. You need to use different libraries and different bases. And I think I said they're light, right? So they're measuring in megabytes as opposed to gigabytes. And they also start much faster. So, if you need to scale up an environment, I'm talking milliseconds or seconds versus VMs, containers are going to be the win. And then these days, a lot of the COTS, commercial off-the-shelf products, are starting to package more and more into containers and giving us greater flexibility with how we want to deploy them. So, comparing them, I tried to put a good overview right here. Basically what they are, it's really light versus heavy, control versus non, quick versus fast. So, microservices versus monoliths. These are all really the reasons why you would want to see the differences between the two. So, last but not least, I don't think we'll ever see a world where one beats out the other. I mean, we'll never see VMs become the way of the Betamax or the HD DVDs. They will be around, and there are reasons in real applications why you'd want to deploy VMs. So I don't think we'll ever be in a fully containerized environment. Hey, could be wrong. We'll see. But so when do you choose a VM versus a container? So first, if you have an application requires the entire host, if you need large amounts of resources, large amounts of RAM, CPU, that kind of thing, you're going to get a better, traction and use out of your host computer from a VM. If you have multiple applications that are working very closely together, think of a monolith, like you have this giant application that runs in, 1.5 gigs of RAM and, has all these pieces that you can't pull apart. A VM is probably a better choice. If you need full isolation of that environment, so if you need to take that, make sure that nothing else can touch it, a VM is going to be a better choice. And if you need a specific version of an OS, think an older version or a specific version of maybe Linux or something along that line, a VM is probably going to give you a better choice of instances where that's applicable. And then finally, a lot of the COTS applications out there, don't have container supports. Think like ERP systems and bigger enterprise systems. You're probably going to have to or be stuck with a VM, at least until they get to the place where they start breaking up their own code into smaller components that support containers. And then finally, when to use a container? Well, first, if you really, really want to get the most out of your servers, deploy lots of applications to it, containers will give you the best bang for your buck. Just to give you, a little bit of context there, on my host PC here, I can probably run somewhere around 20 containers in about 16 gigs of RAM. With a VM, I'm probably running one, maybe two VMs at the most. So, from at least from the developer perspective, and really anywhere you're running more instances on a machine, you're going to get better density and more systems that can be deployed in using containers. If you need to be able to scale your applications out quickly and seamlessly, think e-commerce sites and spikes in traffic, and you need to meet that elasticity with demand. Containers are going to start in seconds or even milliseconds. If you had to start a VM, it's going to take you minutes. So the traffic spike could be over by the time you even respond to it. So, containers are much quicker to get you out there. If you need to move the workloads around, so if you have, want to deploy that application to a qual, to a prod, and have the same exact environments, containers are lighter, they're easier to move, they're consistent across all environments. It gives you that same consistency no matter where you go. And then finally, last point, if you're trying to move to a modern architecture like microservices, there's no way you're going to be able to run microservices in virtual inside VMs. You'd have hundreds, if not thousands, of instances of that, and it would just be impossible to manage and to run. So if you're trying to go to that microservice-like architecture, containers are really where you want to be. So that's all, folks. Hope you learned something today. If you want to know more or want some assistance with the decision making, you can always reach out to us. info@techolution.com. Until next time, cheers. It's great talking to you all. Thanks.